Today we're going to work on graphing a different kind of function, what's called a reciprocal function. You can imagine why it's called a reciprocal function. Notice this is a little bit different. We have an x, our variable, in the denominator. So we could have, it doesn't just have to be x, we could have more than that, maybe x plus 2 in the denominator. Some different variations of that. But our variable is going to be in the denominator. That's going to make a different kind of graph than we've seen before. So let's take a look at that graph. Here we have y equals 1 over x. So I'm going to make a table of values before we put in our calculator to kind of see what this graph is doing, to get to know it a little bit better. So some easy points I can put in. If I put in a 1 for x, then 1 over 1 will equal 1 for y. So the point 1, 1 will be on the graph. If I put in a 2 for x, then y will equal 1 over 2, or 1/2. So 2, 1/2. If I put, let's say, a 4 in for x, I'll get 1 over 4 for y. So we're getting a little bit. That was 3. Hold on 1 second. So 1, 2, 3, 4, and 1 over 4. Let's see what happens if I put in a 10. I get 1 over 10, right? So we're getting closer and closer and closer to this 0. You see it's going down, 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 but it's not touching this 0. If I put in a million, we're going to get 1 over 1 million. I think that's enough zeros. So it's never quite going to touch this x-axis here. It's going to get really, really close, but it's never going to touch that. All right, let's see what it's doing between 0 and 1. If I plug in a 0, then I get 1 over 0. And 1 over 0 is undefined. Anything over 0 is undefined as a fraction. We cannot do a fraction with 0 in the denominator. So this is undefined. So what I'm going to do here is I'm going to draw a dashed line right there at 0. Because no value at 0 is going to work. And this is what's called a vertical asymptote. An asymptote is where a function's undefined. It's never going to have a value. So our graph is never going to cross that line. It's never going to go through there. At 0 of our x value, it is undefined, so we have nothing there. It's called a vertical asymptote. You guys are going to look at some different vertical asymptotes today. So let's see what happens between a little bit bigger than 0, I guess. If I put in a 1/2, well, 1 divided by 1/2 is equal to 2. So 1/2 2 would be a point. If I put in 1/4 for x, 1 divided by 1/4 is equal to 4. So the 1/4 mark here, I would get 1, 2, 3, 4. So you'll notice it's doing the same thing that it did over on the right side of my graph here. So basically, it's going up, and it is never going to touch that 0, that y-axis. It's going to get really close, though. Really, 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 really close, but never actually touch it. All right. I'm going to erase this now. Let's see. And look at the negative side of this graph. So let's make another table of values, x, y. If we plug in a -1 for x, -1. For y, we'll get 1 over -1, which is just equal to -1. So -1, -1 is going to be another point on this graph. If we put in a -2, 1 over -2 is -1/2. So -2, -1/2. If we put in a -4, we get -1/4. So you can see it's happening exactly what happened over here on this side. So this is going to go and go and go and get really close to this line, but never actually touch it. And if we put in, say, a -1/2, then we get 1 over -1/2, which is equal to -2. And you'll see it's doing the exact same thing that it did right up here. So it's going to go down like this, down, 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 and never actually touch this y-axis. So we have a vertical asymptote. We actually also have a horizontal asymptote. The vertical asymptotes are really easy to find because we just figure out when the denominator will equal 0. The horizontal ones, for now we just have to graph them and see if we can find them or not. So this is a horizontal asymptote. So the graph's going to get really, 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 really close. It's getting closer and closer and closer and closer and closer and closer in there, but it's never actually going to touch. Same thing with the vertical asymptote. It's getting closer and closer and closer and closer, but it's never actually going to touch that. All right, let's look at one more graph. So this is a question that you'll see in class. Sketch the asymptotes and the graph of each function. Identify the domain and the range. So hopefully remember the domain and range from last class. So if I graph this, also we can graph them on our calculator, of course. This is the graph of f of x is equal to 1 over x, which we did on that paper right there. So you can graph them on the calculator. It won't show you the asymptotes, but you can get a pretty good idea of where the asymptotes are. I think it's good to do a couple by hand to kind of get familiar with them. So just by looking at this, I know that my graph is going to be undefined when my denominator is equal to 0. So something plus 3, when that equals 0, I'm going to have a vertical asymptote. All right, so I know that at -3, -3 plus 3 is 0. That is going to be undefined. Undefined. So at x equals -3 right here, I am going to have a vertical asymptote. This is x equals -3. We have a vertical asymptote right there. Should have another horizontal asymptote somewhere else in this graph. The vertical asymptotes are the easiest to spot. All right, now I'm going to put in a couple of values. And we can see, look at kind of some easier values maybe. Let's see. If I put in a -2 in here, then I have -2 plus 3 is 1. 2 over 1 is 2. 2 minus 2 is 0. So -2, 0 is a point on my graph. Let's see here. If I put in what's another easy one to put in? How about if I put in a 1? If I put in a 1, 1 plus 3 is equal to 4. 2 over 4 is 1/2. 1/2 minus 2 is -1 and 1/2. So 1, -1, and 1/2. All right. Let's see if I put in a really big number. Let's see what happens if I put in 100. We have 100 plus 3. That's 103. 2 over 103 is a really small number. So it's going to be a very, very, very small decimal. Minus 2, it looks like we're approaching this -2 value, but we're never actually going to touch it. So I'm going to draw in a horizontal asymptote here at -2. All right, so based on this, I have both my asymptotes. I can probably guess pretty well that my graph is going to be looking something like this. It's going to be going up like that, and it's going to be going over like this. And just like the other graph, we are probably going to be having something like this and like this. All right, so let's put in our calculator to double check. See what it looks like. Move this over here so I can see my equation. All right, menu, graph, function. All right, let's change this around. So we have a 2 on top. On bottom we have x plus 3 and minus 2. If I graph that, let's see, does that match up with what I have? It looks like it matches up with what I have. One other thing we can check is by looking at the table, Control T. Alright, if I go to this x equals negative 3, so I'm going to go up on my table to negative 3, look at that. There's a number sign and a U, and if I go down here it says undefined. So there's definitely an asymptote there. There's no value at negative 3. Alright, so sketch the asymptotes. We sketched them. Let's make the equations for them too. So this one's going to be x equals negative 3. My other asymptote here is going to be y equals negative 2. Then we need to identify the domain and the range. So the domain, that's all of my x values, right, that we have here. So we could say the domain is all real numbers except 1, right? Except x equals negative 3. The graph is, we have a value for all of our x values except for right here. And we have a value for the rest of our x values. The range is going to be the same thing. That's our y. We could say all real numbers except y equals negative 2. So that's what you guys are going to be doing in class. Bring any questions that you have. We'll see you there.